Greetings, Calc 2 students. I made this video to talk about section 9.3, number 46 in our book. So again, if you're working on this on WebAssign, the numbers you have might be slightly different, but it follows the same pattern. So the question says that there's a room that has a volume of 180 meters cubed that contains 2% carbon dioxide when we start. And then fresh air is being pumped in at 0.05% carbon dioxide at a rate of 2 meters cubed per minute. And the air gets well mixed and then gets pushed out of the room at that same rate of 2 meters cubed per minute. So we're asked to find the percentage of carbon dioxide in the room as a function of time in minutes. So this is the part that can be tricky. We're supposed to find a P of T, that's the percentage of the CO2 that's in the room as a function of time. So if Y is a change in the CO2 in the room, the carbon dioxide, then P of T equals, well, I take the change of carbon dioxide and divide it by the amount of volume of air in the room, which is 180, and multiply that by 100%, and then that would be my percentage. Okay, so first thing I need to do is find the actual change, and I'll call that Y of T. When I'm finished with it, I'll divide it by 180 and multiply by 100. So dy dt, when we're doing mixing problems, it's the rate in minus the rate out. And so in my case, the rate in is 0.05% carbon dioxide times 2 meters cubed per minute. So I changed the 0.05 in from percentage to 0.0005 as a decimal and multiplied it by 2, and then minus y times 1 over 180, so that's the rate that's moving out, times 2 meters cubed per minute. And so when I simplify that, I get dy dt equals 0.001 minus y over 90. So then what I have to do, because I wanted to do this as a separable differential equation, I took this 0.001 and I multiplied by a common 90 over 90 because I wanted a common denominator. And when I do that, I get 0.09 and then minus y all over 90. So I did a little bit of algebra there just so that I could separate things. So then I took this 0.09 minus y and divided it over to the other side. That's what happened down here. And then I multiplied this dt to the other side. So then I have now separated that differential equation. So I took the antiderivative of both sides. So I get natural log the absolute value of 0.09 minus y on the left divided by -1. And that's equal to t over 90 plus some integrating constant c. So now what we'll do is find out what is this integrating constant c. And so we're told that when time is equal to 0, the amount of carbon dioxide in the room is 0.2%. So I did it in decimal form, so I did 0.002 and I multiplied it by 180. So there is 0.36 meters cubed of carbon dioxide when we are starting initially. So I plug that into my equation. So I get natural log of the absolute value of 0.09 minus 0.36 divided by -1. I plugged in the 0 because time was 0. And so on the left-hand side, this would be a negative number, but since it's inside the absolute value, I get 0.27. And so I have the natural log of 0.27 divided by -1, and that's equal to c. Of course, I could write that as minus natural log of 0.27. So I plug that value in for c into my solution from up here, and I plug that c in right there. And so I get the absolute value, the natural log of the absolute value of 0.09 minus y divided by -1 is equal to t over 90 minus c, but we found that c to be natural log of 0.27. So then I just solved for basically y, And what I did was take exponential e to both sides. And so I have the absolute value of 0.09 minus y on the left, and I have e to the negative t over 90 plus the natural log of 0.27 on the right. By the way, I multiplied everything by -1. That's why this changed to a negative. This changed to a positive. And then I simplify and I get the absolute value of 0.09 minus y is equal to 0.27 times e to the negative t over 90. So we have to be a little careful here about what to do with this absolute value. So I have 0.27 e to the negative t over 90 is always bigger than 0. And I sort of wrote out the case where t is bigger than 0, and that's because time is moving on. But that would always be positive. It doesn't matter if t is less than 0, but I'm just sort of emphasizing the case. As time is moving on, this thing is always going to be positive. So since they're equal, that means this thing on the left always has to be positive as time goes on. So for when time is bigger than 0, the absolute value of the absolute value of 0.09 minus y is the same as y minus 0.09. So as time is bigger than 0, I have y minus 0.09 equals 0.27 raised to the negative t divided by 90. So then I just added the 0.09 to both sides, and I have y. So the second part then says find p of t. So the change in carbon dioxide is this 0.27, e to the minus t divided by 90 plus 0.09. But the percentage that the question is actually asking us to find, volume of carbon dioxide in the room, is now I have to multiply by 100 and divide by 180. So once again, that's because I defined the P to be the change in the carbon dioxide divided by the volume of air in the room times 100 to get that percentage. So that's what I did. I took the y divided by 180 multiplied by 100, and when I do that, it simplifies to the percentage of carbon dioxide in the room as a function of time is 0.15 e to the negative t divided by 90 plus 0.05. And then the next part of the question says, what happens as time goes on? What will the percentage stabilize to? And so we have to sort of be careful about this, because remember that P of T is in percent. So I'm going to write in percent. So remember our answers in percent. But as time goes on, as time goes off to infinity, I have, as time goes bigger and bigger and bigger, I'll have the limit as t approaches infinity of P of t. And since we have this term has a negative in the exponent, that is the same as 0.15 divided by e to the t over 90. And we're going to take its limit as t approaches infinity, and then plus 0.05. And so this term will go to 0, and that'll equal 0.05. Now remember, that's a percentage, so we'll have 0.05% as time goes off to infinity. Okay, I hope this video helps. Please let me know if you have any questions.